Alright, you guys, we are in section 5, chapter 4, and this section is about isosceles and equilateral triangles. So it's important to realize here that the angles and sides of isosceles and equilateral triangles have special relationships. So isosceles triangles are pretty common in the real world. You can frequently see them in structures such as bridges and buildings, as well as in art and design. The congruent sides of an isosceles triangle are called its legs, and the third side is called the base. The two congruent legs form the vertex angle. The other two angles are called the base angles. The isosceles triangle theorem says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So given two congruent sides, you have two congruent angles. The converse of the isosceles triangle theorem says exactly the reverse, that if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So given two congruent angles, you have two congruent sides. So our first question here says, is segment AB, here's segment AB, is it congruent to segment CB? Well, to tell if those two sides are congruent, we look to the opposite angles, our base angles, and we see that our base angles are congruent. So our answer to this is yes. And our explanation is by the converse of the isosceles triangle theorem. Because again, the converse says that if we have two congruent angles, then we must have two congruent sides. The next question says, is angle A congruent to angle DEA? So angle DEA is this angle right here. Or I guess, oops. You can mark it as such. Well, yes, our answer here again is yes. And it's because we see that we have two opposite sides that are congruent. And the isosceles triangle theorem says that if you have two sides congruent, then you must have two angles that are congruent. So yes, by the isosceles triangle theorem. Alright, so you try these two. Is angle WVS congruent to angle S? Is segment TR congruent to segment TS? Explain for both. And then number 2, it says, what is the value of X? So we see that we have two congruent angles, which means our sides must be congruent. So we should be able to find the value of X. Alright, so once you've worked out these two problems, go ahead and move forward to the next slide. So you might want to pause here. Here we come to another no-name theorem. This theorem says that if a line bisects the vertex angle of an isosceles triangle. So here we have this line bisecting the vertex of the isosceles triangle. Well, since it's bisecting the angle, we know it's creating two congruent angles up top. But the theorem says that if it bisects this angle, then this line is also the perpendicular bisector of the base. So not only will it bisect the angles up top, it'll bisect the segment below, and it'll intersect at a 90-degree angle. So this is a no-name theorem. Again, don't refer to it as theorem 4.5. That's not a name at all. So here we have, what is the value of X? To find the value of X, we want to look at this triangle here. 54 is kind of out in the middle. It's actually over here for angle A. And then I know that this line right here, since it bisected my angle up top, and since this is an isosceles triangle because of the markings here, then I know these angles are congruent. I know that this angle bisector is also a perpendicular bisector by the theorem above. So I know that this angle right here is 90 degrees and this angle right here is 90 degrees. And since the angles up top are congruent, then I know this is x right here. Well, you know triangles add up to 180, so I can say 54 plus x plus 90 is equal to 180, and I can solve. So 54 plus 90 is 144, plus x equals 180, and then solving I would subtract 144 from each side, so x would be equal to 36. The second problem says, suppose the measure of angle A equals 27. All right, so let's go back over here. Oops. Okay, I can't erase anything there. But it says, suppose the measure of angle A is 27. What is the value of x there? All we have to really do is substitute the value of 27 for 54. So 27 plus x plus 90 is equal to 180. So doing the same thing, 27 plus 90, so x plus 117 equals 180. And then subtract 117 to the other side, so x is equal to 63. All right, now let's take a look at a few corollaries. A corollary is a theorem that can be proved easily using another theorem. Since a corollary is a theorem, you can use it as a reason in a proof. So here's the corollary to theorem 4.3, and recall theorem 4.3 was the isosceles triangle theorem. So the corollary to that says if a triangle is equilateral, then the triangle is equiangular. So equilateral, all the sides are the same. Equiangular, all the angle measures are the same. So if a triangle is equilateral, then the triangle is equiangular. Corollary to theorem 4.4, the converse of the isosceles triangle theorem, says that if a triangle is equiangular, then the triangle is equilateral. So here it's basically the same thing as the isosceles triangle theorem, and its converse is just referring to equilateral triangles. All right, it's your turn. You try problem 1 and problem 2. Once you finish, that wraps up this video. So please make sure you took good notes. You copied down my examples as well as yours, and you took notes from this video. All right, thanks. I'll see you in class.